heating. Radio wave heating is a method of heating using a radio frequency electromagnetic wave. Unlike a conventional heating, which is transfers the heat from the surface to the inside, this radio wave heating transfers the heat directly within the material. This allows for faster, more uniform, and energy efficient heating. This radio wave heating is widely used in industries such as food processing, dry wooding, plastic building, and also for medical treatment. Now, let's look at the definition of radio wave heating. Radio waves are a type of electromagnetic radiation with the lowest frequencies and longest wavelength in the electromagnetic spectrum. They are fundamental to modern technology, serving as the invisible backbone for wireless communications, including standard broadcast radio, television, cellular networks, Wi-Fi, and also radar systems.
To understand how radio wave heating works, we have to look at the microscopic level. The process relies on a mechanism called dielectric heating. When a material is placed between two electrodes, a high-frequency alternating electric field is applied. This field switches polarities millions of times per second. Most materials, especially those containing moisture, are filled with polar molecules like water. These molecules act like tiny magnets, having a natural positive and negative end. As the external electric field flips back and forth, these polar molecules are forced to rapidly rotate and realign themselves with the changing field. This incredibly rapid flipping causes intense intermolecular friction. Think of it like rubbing your hands together on a cold day, but happening millions of times a second at the molecular levels. This friction directly converts the electromagnetic energy into thermal energy. Because this friction happens simultaneously throughout the entire object, we achieve volumetric heating. The material doesn't just heat from the outside surface, it heats uniformly from the inside out instantly and efficiently.
Now, I want to talk about the important principles that involve in radio wave heating. First, electromagnetic wave. Electromagnetic waves are waves that carry energy through a space without needing a medium. In radio wave heating, radio frequency waves are used because they can transfer energy into material efficiently. These waves are part of the electromagnetic spectrum and have lower frequencies compared to microwave or infrared waves. Next, the main principle involved is dielectric heating. This happens when radio waves pass through a material that contains polar molecules, such as water. The alternating electric field causes these molecules to continuously align and realign with the changing field. Next, this rapid movement creates molecular friction because the molecules collide with each other repeatedly. As a result, the electromagnetic energy is converted into heat energy. The more the molecules move, the more heat is produced. One important advantage of radio wave heating is internal heating. Unlike conventional heating, where heat moves from the outside to the inside, radio wave heating allows energy to penetrate the material and heat it from within. This makes the heating process faster, more uniform, and more efficient.
Now, I would like to explain about application and example. First of all, we use radio wave heating in food processing in industry to dry, pasteurize, and sterilize food products. It helps heat food quickly and uniformly, reducing processing time while maintaining food quality. For example, drying fruits, vegetable, grains, and bakery products. Second, in materials manufacturing to remove moisture from wood before it's used in furniture and constructions. This process helps prevent warping, cracking, and fungal growth. For example, drying lumber and plywood during manufacturing. Third, we use radio wave heating in textile industry to dry fabrics, yarns, and textile materials after washing and dyeing. It provides faster and more uniform drying compared to conventional method. For example, drying cotton fabric after the dyeing process. We also apply radio wave heating in medical application in certain medical treatments where control heat that apply to body tissues. The heat can help destroy abnormal cells or relieve pain. It is a highly localized and minimally invasive technique used across various medical specialties to treat pain, eliminate cancer cells, and reshape tissues. For example, radio frequency ablation machine RFA used to treat some tumors, heart rhythm disorder, liver, and kidney cancers. And lastly is seed pasteurization and sanitization. Many plant diseases are carried by fungus spores or bacteria hiding on or just beneath the seed coat. Heating can target and destroy dangerous pathogens like Salmonella, E. coli, or Fusarium fungi. The heating is highly controllable and uniform. It pasteurizes the seeds without killing the plant embryo, keeping the seed's germination rate exceptionally high for future planting. For example, management of alfalfa and sprout seeds or bud grain seeds like corn and wheat.
Now, I will explain the advantages of radio wave heating. Firstly, radio wave heating provides fast and efficient heating. Radio waves are a type of electromagnetic wave with frequencies ranging from approximately 3 kHz to 300 GHz. In heating applications, radio frequency waves interact with certain materials by causing polar molecules and charged particles inside the material to oscillate. This molecular movement creates heat energy directly inside the material, allowing the heating process to occur faster than conventional methods which transfer heat from the outside surface to the inside. Secondly, radio wave heating provides more uniform heating. Because the energy can penetrate into the material, heat is distributed more evenly throughout the object. This reduces the chances of overheating the outer surface while the inner region remains cool. The characteristic is especially useful in food processing and industrial manufacturing. Another advantage is that radio wave heating is a non-contact heating process. Unlike traditional heating methods that require direct contact with a heating element or flame, radio waves transfer energy through electromagnetic fields. This reduces contaminations and makes the method suitable for applications that require high level of cleanliness, such as medical treatments and food sterilizations. Finally, radio wave heating offers precise control over the heating process. Engineers can adjust the frequency, power level, and exposure time of the radio waves to achieve the required temperature. This improves product quality, reduces energy waste, and increases the efficiency of industrial processes. Although radio wave heating has many advantages, there are also several limitations that needs to be considered. The first limitation is the high cost of equipment and installations. The radio wave heating systems require specialized components such as radio frequency generators, power supplies, control systems, and shielding structures. These technologies can be expensive to install and maintain, especially for small-scale industries. The second limitation is that not all materials can be heated effectively using radio waves. The efficacy of radio wave heating depends on the electrical properties of the material, especially its dielectric properties. Material with low ability to absorb electromagnetic energy may not heat efficiently, making this method unsuitable for certain products. Another limitation is related to safety and electromagnetic interference. High-power radio frequency waves may interfere with nearby electronic devices if the system is not properly shielded. Long-term exposure to strong radio frequency fields may also pose health risks, so strict safety standards and protective measures must be followed. Lastly, achieving uniform heating can sometimes be challenging, especially for materials with irregular shapes or different thicknesses. Therefore, proper system design, frequency selections, and regular maintenance are required to ensure effective heating. In conclusion, radio wave heating is an advanced technology that uses electromagnetic radio waves to convert electromagnetic energy into thermal energy within a material. The process is mainly based on the principle of dielectric heating, where alternating electric fields causes molecules, particular polar molecules such as water, to continuously rotate and generally heat through molecular friction. Radio wave heating has become an important technology in modern society due to its speed, efficiency, and ability to provide controlled heating. It has many practical applications, including microwave ovens used in daily life, radio frequency welding for joining plastic materials, and medical diathermy, where radio waves are used to produce heat inside our body tissues for therapeutic purposes. Although this technology has some limitations, such as high equipment costs, limited compatibility with certain materials, and the need for proper safety measures, the advantages often outweigh the disadvantages. With continuous improvements in radio frequency technology, radio wave heating is expected to become even more efficient and widely applied in the future industrial and medical fields.